Okay, we're going to continue with this paper. So let's start with question 2. Okay, then for this question, you have to isolate this truck. Okay, and you are supposed to label 3 other forces acting on the truck only. So number 1 is there's the weight acting on the box, but since the box is on the truck, the box will exert a force onto the truck. So therefore you have, okay, make sure it passes through the box center of gravity. So this one is the force of the box acting on the truck. Okay, then of course, because the truck is on Earth, so the truck will be pulled by the Earth gravitational field. So therefore, there's also the weight of the truck. Okay, then of course, because the truck is having contact with the ground, you will also have the normal contact force. Okay, some of you may argue that, okay, since the box is moving through air, it will also experience air resistance. So okay, fine, you can tell me that there's air resistance as well. Some of you may also argue that, okay, because the truck is in motion, so there will be friction. Okay, but friction in this case is quite tricky, because if you consider the wheel rotating, then the friction will point forward. But if you consider the truck as one rigid body that doesn't have a rotating wheel, then the friction will point to the back. Now, like I have said many times, it is not that critical if you have declared the friction force in the wrong direction, because eventually the mathematics will tell you whether the direction you declare is correct or wrong. Okay, so in this case, I will consider the wheel as rotating, and so it rotates this way, so therefore the friction is pointing forward. Okay, so basically that is all the forces. Then in part 2, I challenge you to write an expression for F. To do that, you cannot simply use Newton's second law, because then you have too much variable. So this F that I'm referring to is this one, it's not the F net. Okay, so some of you may just give me F equals to ma. That's wrong. The F in F equals to ma is the F net. Okay, in this case, the F is just this singular force. So a smart way of doing it is that you can just take the pivot here, because by putting the pivot here, you basically eliminate the consideration of these two forces. You only have like this much. Then after that, you just need to declare the direction, the distance here, and then the distance here, and finally the distance here. In this case, when I first designed this question, I actually forgot to put down there, do not consider air resistance. Okay, because if you have air resistance, that means this air resistance will give you another moment. Okay, so in this case, I am assuming there is no air resistance. Okay, so how to write the expression? So you take the moment at P. So please, we have the habit, it's a good habit to declare where is your pivot. So taking moment about P, then the sum of clockwise moment must be equals to the sum of counterclockwise moment. So in this case, the only counterclockwise moment is just this force by the box acting on the truck, and this force is actually the weight of the box, right? So on the counterclockwise side, which is this one, is just the force of the box acting on the truck, essentially is the weight lah, multiplied by this distance. Okay, because this is the line of action, right, of this force, and this is the pivot. So let's declare this d1, so times d1. Yeah, then for clockwise moment will be created by this force. Okay, because if you hold your pen like that, you pivot your pen at the bottom, you pull to horizontally, you get a clockwise moment. Similarly, the weight will also give you a clockwise moment. Okay, but you cannot add them up without multiplying first. So for F, I have to multiply, okay, this distance, this is d2. Okay, the reason why is the line of action of the force F is here. This is the line of action, the horizontal one. So the perpendicular distance from the line of action to the pivot, okay, is d2. So therefore, you have F times d2 plus the weight of the truck will also give rise to a clockwise moment. So line of action of the force is here. Okay, so the perpendicular distance is somewhere here, d3. Okay, so plus W times d3. Then you make F the subject and you'll be able to get an expression of F, the force F. Okay, next. For this question, it is pretty straightforward. It's just a simple moment question. Let's see, did I put any tricks here? Okay. The trick here is that I go and put total moment. Okay, so because of this word total moment, therefore actually you do not really need to do any calculation, because you see this 100 Newton about this pivot will give rise to a clockwise moment. Then this 100 Newton on the right of the pivot will give rise to a counterclockwise moment. So basically the moment caused by this force and the moment caused by this force will eventually cancel out. So the total moment will be 0 Newton meter. Okay, for those of you who cannot conceptually solve this question, you can do your own calculation. Okay, now for your part C. Part C, now I have moved the string from this place to here. Now some of the students will assume that string R will have the same tension as your previous question. Your previous question, okay, they may think that, oh, okay, I will have 100 Newton, but please take note, now the string has changed. PQ, this one is RQ. So actually I have given you a hint that the tension here would change. Now, let's say I didn't hint you. Let's say I still put string P. Will the tension be the same as previously? Okay, the answer is no. Okay, it won't be the same. Reason, the weight of, let's say I keep the weight of this beam the same between part B and part C. But because I move my string Q, the moment caused by this string and the moment caused by this string, okay, must be the same in order for it to balance, right? But now the distance has changed. This means that the tension in Q must be different. And because of that, okay, if this is different, therefore this one must be different as well. If not, your Newton's second law will not hold. Now, for those who are confused, what I mean is that in order for it to be balanced, F net must be 0 and M net must be 0, right? So F net, if you expand it out, basically it consists of the weight of the beam minus the tension in Q minus the tension in R, right? And they have to be 0. So if now your tension in Q has changed, your R must change as well, right? If not, you cannot balance off the W. Okay, so even if this is string P, okay, it will not be 100 Newton anymore. It will not be the same as your part B. Okay, now let's get back to what this question wants. So if you just want to solve this question, okay, you have two unknowns. You do not know what is the tension in R, you do not know what is the tension in Q, but you know the weight of this thing is 160 Newton. And you want to find this guy, right? So where should you put the pivot? Well, the question has labeled the pivot here, but I have told you before, right? The pivot in your calculation is just a mathematical entity. So you can put your pivot anywhere you want. So since you are only interested in finding this is the other unknown that you don't really need. So therefore, you can declare the new pivot here, let's call it Y. Okay, so down here, you just need to take moment about Y. Okay, and then you just do your sum of moment clockwise equals to sum of moment counterclockwise. Yeah, and if you look at that, if you take your pivot here, basically you do not need to consider the tension in R anymore because the distance here will be 0. The weight of the beam will cause a clockwise moment. This one will cause a counterclockwise moment. So just substitute in accordingly. So this one is counterclockwise moment, right? So tension Q multiplied by the distance will be 1.8 minus 0.3. Down here it will be 160 multiplied by 1.8 divided by 2. So eventually just press your calculator, 160 times 0.9 divided by 1.8 minus 0.3. So you will get 96 Newton. Done. Okay, this one is your energy question. So just label out all the things first. So this is 2.5 kg. Vertical distance is 1.8. Speed of sphere at Q is 5 meter per second. Distance PQ is 5 meter. Okay. I think part A you just refer to your textbook. There must be 3 components. Cannot be created nor destroyed. Can only be transferred from one body to another body. Can only be converted from one form to another form. Okay, loss in GPE. Loss in GPE I think is quite easy. You just take PE equals to mgh. So therefore you will get 2.5 times 10 times 1.8. So your answer will be 45 joules. Okay, then followed by the gain in KE of the sphere as it travels from P to Q. So the loss of PQ must be equals to the gain in PQ, right? Wait a minute, is there any any tricks? Let me see. Gain in KE must be the loss of PE. Is it a smooth slope? They didn't say. Okay. Oh, good. We cannot just say that. Okay, the reason why I paused just now is because if I am assuming the loss in PE is equals to the gain in KE, I'm assuming there is no energy loss. But I got a feeling that there is energy loss because of part C. You see, they already hinted to you that B part 1 and B part 2 is different. So I know that I cannot just put 45 here. So when I relook at the question, I realized that at part P, it is initially at rest, and at Q there is some velocity, meaning that I can actually calculate what is my gain in KE. So my gain in KE must be equals to half mv square, okay, minus 0. Okay, because why I minus 0? This 0 represents the amount of KE at P. Okay, so once I do that, I just need to put in my numbers. I will get 31.25. So, like I said, it's safest to keep as 3SF. Okay, just here bracket 3SF. Okay, you'll be fine. No one can fault you if you have stated everything correctly. So as you can see, 45. So the loss in PE is not totally accounted for by the gain in KE. So there must be some energy loss. So it means that there is some energy loss. So in this case, I didn't consider friction in here. So I can say that the energy loss is due to work done against friction and air resistance. Okay, now the common mistake among students is that they will just say, oh, energy loss due to friction. Okay, that is not a very precise or accurate explanation, because energy loss is in joules, friction is in Newton. So you must go and put in the work done against what and what. Yeah, so I'm supposed to calculate the average frictional loss. So in this case, I'm assuming, okay, no air resistance. Okay, because if not, I would not know how much energy is spent on overcoming the work done against friction. So in this case, I would know that the work done against friction must be equals to 45 joules minus the 31.1 joules. 31.3 joules. So I would get 13.7 joules. This is the amount of energy I need to account for. And if I express my work done into its formula, it will be the friction multiplied by the distance that it travels. And I know that distance it travels is 5 meters. Okay, this slope. Right? So it will be your friction 13.7 over 5. So I would get 2.74. So it is 2.74 and it's frictional force, so it's Newton. Don't worry about the truncation error. Okay, it's alright. Okay, question 4 is the tricky one. Why am I saying that this is tricky? Because the density is different and your volume is, I think it's different as well, right? Oh, wait a minute. Oh, okay, so it's the density that is different, volume is the same. So because of that, if you go and use D equals to M over V, you will realize that your mass is different. So I suggest you quickly go and put here the mass, okay, and then 2 sphere, 50 cm cube. So just calculate out first. So 8 times 50. Do you need to change to meter cube? No need, right? Because here cm cube, here also cm cube. So down here, this will become 400 gram. 2.8 times 50. 140 gram. And for the water, you have 100 cm cube, so you will get 100 gram. Okay, so the mass is different. Explain why the temperature of both spheres cannot be greater than 100. So you have to say, number one, they are in thermal equilibrium. I'm not going to copy out everything, okay, because I'm actually running out of time and because I need the time, yeah, to play game. So anyway, you are the one learning. I just need to teach you, right? Okay, yep, justified. Okay, thermal equilibrium is the first point that you must mention. And of course, thermal equilibrium, if you just mention this alone, you are actually paraphrasing this line. So this alone will not give you the full credit. What makes a temperature constant is because there's no net, okay, transfer of heat, okay, at thermal equilibrium. And hence, there will be no temperature change and it won't go greater than 100. Yep. And of course, because water boils at 100, right? Unless you put it in hot vapor, then you can get more than 100. But I think because this is just 1 mark, you can leave it there. If it is 2 mark, then you need to elaborate a bit more because water boils at 100 at constant temperature. So if you put it in liquid water, it will be just 100, that is the max. Okay, but if you put it in vapor, then it can go above 100. Okay, this one, remember. Okay, now calculate the heat capacity of the sphere made up of X. So, heat capacity. Let me see. 1 megawatt suspended for 10 minutes. The sphere is transferred beaker A. Oh, okay. Actually, you don't need to read so much. Now, what is given here is the specific heat capacity is per kg. What they want is the heat capacity. So heat capacity, it is dependent on the mass. So what you need to do is very easy. You just need to play with the unit. So can you see here is joules per kg per degree C. So I will just write it here so that you can follow the trend. So I have joules per kg per degree C. This is specific heat capacity. Okay, you want to change it into heat capacity, which is joules per degree C. So what is the difference between this unit and this unit? The kg here, right? So what do? You multiply by kg. What is this? This is the mass, specific heat capacity, heat capacity. Heat capacity is with a big C. Yeah, so you just need to do that. So this one, okay, if you have confidence in your formula. Actually, this one is given in the formula list. So this one is specific heat capacity, small c, multiplied by the mass will give you the big C, heat capacity. So therefore, big C is here. X will be 380. The mass we have already calculated. Be careful, the one that we calculated is 400 gram. This one is in kg. So down here, you have to put 0.4 kg. Okay, and then you will get the answer. 380 times 0.4 kg, you will get 152 joules per degree Celsius. From your answer to B, explain why sphere B will cool down at a slower rate than sphere Y, and I have to give numeric value. So I have to use my answer in B. So since I'm comparing things, right, I may as well find out what is my heat capacity of Y. So heat capacity of Y, it will be just 700 times 0.14. I will get 98 joules per degree C. Now, why am I finding the heat capacity, and why am I using this to do a comparison here? The reason why is because the mass is different. Okay, so if I use the heat capacity, I do not need to consider like, oh, why this one different mass. Okay, if I use specific heat capacity, it is per unit kg, right? So if I use specific heat capacity, I need to make my mass a control variable. But if I go and use heat capacity, then my difference in mass is already taken into account. Okay, because I multiply by the mass of the subject that I want to test on. Okay, this question, if you have doubts, please approach me. Okay, so for now, so if you look at this, my specific heat capacity here is larger, my heat capacity here is lower. Okay, now I have to make one assumption, that is the rate of heat loss, right? Because this value only tell me that, oh, if X is supposed to drop by 1 degree C, X must give out 152 joules of energy. And if Y decrease 1 degree C, I have to give out 98 joules of energy. Yeah, so just by looking at this, well, you can say that, oh, okay, Y only need to lose 98 joules, it will decrease by 1 degree C. This one need to lose 152, so therefore X will not be cooled down as fast. But there's an assumption. The assumption is the rate of heat loss for X and Y must be the same. What do I mean by that? Now, if you assume X lose heat at 200 joules per second, okay, heat loss for X. But if my heat loss for Y is made up of wood, is something insulator, it loses heat very slowly, let's say 10 joules per second. Which one will cool down first? This one, right? Because within 1 second, it will already lose 200 joules, that means it will decrease by at least 1 degree Celsius. This one, after 1 second, it will not decrease by 1 degree C, because only lose 10 joules per second. So therefore, when you are explaining this kind of question, you have to make your assumption very clear. You are assuming, okay, X and Y has the same rate of heat loss. You must state your assumption. So therefore, since X has a higher heat capacity, bracket 152 joules per degree C, compared to Y's heat capacity. I'm writing this lengthy thing because it wants me to state the relevant numeric value. So this is 98 joules per degree C. So therefore, okay, X would cool down slower because it need to lose more energy, okay, to decrease 1 degree C. First stop. Can? Okay, calculate final temperature of beaker B. Now, beaker B is which beaker? Sphere X is transferred to beaker A, sphere Y is transferred to beaker B. Okay, good. Common mistake for this question is that they think that the water in B has an initial temperature of 100 degrees C and then it becomes 30 degrees C. Actually, it's wrong. So what happened is, in beaker B, you have water of 30 degrees C and you actually have your sphere Y, which is at 100 degrees C. This is before they come into contact. So what happens after they are put in together? Okay, eventually they will reach thermal equilibrium, right? They will become the same temperature. So the water will become temperature T, the sphere will become temperature T, but we do not know what is this value. Okay, so that is what we want to find out. So use your energy equation. So energy loss, okay, by sphere Y must be equals to the energy gain by the water. Yeah, so once you have that, okay, use your MC delta theta. Do you need to use MC delta theta? Oh yeah, specific heat, right? So your delta theta here will be energy loss. So it will be 100 degrees C minus the final temperature, right? Down here will be the mass of water multiplied by the heat capacity, specific heat capacity of water. This is heat gain, so it will be T minus 30 degree. Okay, so the T is not necessarily always at the back. You must make sure that this difference is a positive value. Yeah, so once you have that, put in your values. So remember it's in kg, so this one is 0.14. This is 700. This is 100 minus T. This one is 0.14200 T minus 30. Okay, then you all solve the algebra yourself. Okay, your question 5. Label at P, angle of incidence and angle of refraction. Remember, whenever you have this question, draw the normal. This one will be your angle of incidence. This one will be your angle of refraction. So if you look, angle of refraction is smaller than the angle of I. This one is having higher refractive index. Label at Q the critical angle. So if you look at here, again, draw the normal first. Can you see that the refracted ray is already along the boundary? That means your angle of, I didn't draw it properly. Your angle of refraction is already at 90, so therefore this guy here must be your critical angle. That is the definition of critical angle. Okay, critical angle is the incident angle whereby the refracted ray is at 90 degree from the normal. Draw the complete, that is reflected. Okay, so if you draw this, draw the complete path and then it's reflected back into the block. So if we do that, this is the one. Tricky part is you need to figure out whether it bounced out or not. So you know that this is a reflection, right? So therefore, this one will also be my angle C. So if you do that, can you see that this is an alternating triangle? So this one is your 90 degree minus C. So this one is your 90 degree minus C. So can you see that this one is definitely less than your critical angle? Right? Correct? Yeah? So therefore it will come out. So as it come out, it will bend away. Yeah? Okay. Calculate the critical angle. So this one, I think I won't insult your intelligence. It's just C equals to I sine. Okay, never mind. I give you the formula that you always use. N equals to 1 over sine C. Okay, then go and work it out. Okay, lower refractive index. I really don't like this kind of question because I don't remember things. So what you need to do is this. You let N equals to say 1.3 versus N equals to 1.8. Okay, and then after that you go and find out how will the C behave. So let's find out. I really don't like this. 1 divided by 1.3. You will have critical angle of 50.3. Critical angle of 33.7. So as you can see, this one, it is very easy to be larger than your critical angle. Okay? So it means that TIR very easy to occur. Fine? So have this understanding. Now if we look at this, so meaning that if you lower the refractive index, your critical angle become larger, your TIR will happen more difficult. So therefore, if you do that, reason number one is if you have a lower refractive index, your angle C will be larger and your TIR will only happen when your angle I is larger than angle C. So therefore, total internal refraction will not happen at the bottom, okay, because if you look at what you have here, this is just nice for the original refractive index. So if you lower this refractive index, your angle C will be much larger and this angle I will not make the cut. Okay, so what happens is that it will get just refracted out. That's it. I do not know what is this second reason, because my only reason is this, that's all. Okay, I'll go and find out. Then I think this is an error. You just need one reason. There's no second reason. Oh, okay. I know what's the second reason. Second reason is that your refractive index must be higher than the atmosphere. Is it in air? It's already in air. Okay, so the outside is already in air. Air is the refractive index. The lowest refractive index that you can get is 1. So anyway, for the sake of this question, maybe they found a material that has a refractive index lower than 1, but that is not possible, because if you get something refractive index lower than 1, that means the speed of light in that medium will be faster than the speed of light in vacuum. Basically, you have exceeded the speed limit of the entire universe. So it won't happen, but for the sake of it, okay, fine. The refractive index must be higher than the refractive index of the external medium in order for TIR to happen. Okay, this external medium is the air, but like I said, you can't get a refractive index